In this video, we're going to go over a system of quadratic equations. I'm going to talk about the types of solutions that you could have, whether it be two solutions, one solution, or no solution. I'm going to go through and solve it algebraically first, and then we'll go back and check our answers graphically using the TI Inspire calculator. Before we get into solving the problem, let's go over the types of solutions that you could get. And I think you could really see this easily when you see the graph. So let's say you had this quadratic and this linear graph. The solution to a system of equations is where they cross. So right there at this intersection, 0, -3, that would be one solution. And then right here, 4, 5 would be another solution. So when x equals 0, the y would have to equal -3. When x equals 4, the y would have to equal 5. In this situation, we have two quadratic equations. Again, they cross twice. They have two intersection points. So one solution would be -1 and 5. The other one would be x equals 3 when y equals 9. Now, a different type would be like if they only crossed one time. So we have a quadratic and a linear. They cross at 4, 2. So this would only have one solution. So that would be okay as well. And then finally, let's say they don't intersect at all. You have this parabola, the red one, and then the line, the blue one. There's no cross, so there would be no solution at all. For this problem, we have a system of quadratic equations, and the tricky thing about solving a system of equations is that you have two different variables. So we have a y, we have an x. You can't just solve for x. So the nice thing about this is that they are both set equal to y. So the first step is that we're going to set them equal to each other because they're both equal to y, and that'll eliminate the one variable. So then you can just solve for x. So as you can see, there's no more y. It's just a typical equation where you got x and you're going to solve for it. So I see that I have an x squared term here and an x term. That means I'm probably going to have to factor to solve. So let's set this equation equal to 0 and then go from there. So that means we're going to have to take away x squared. We're going to subtract 2x, and we're going to also take away 1. And we're going to do it from both sides, the right side and the left side. And that'll leave us with a new equation set equal to 0. Now we can factor, so I'm going to set up my factors, make them equal to 0, and because my a value in front of the x squared is 1, I can look directly to that -4 there, the -4, and think, what are the two factors of -4 that also add up to be -3? And that's going to be a +1 and a -4, so I'll put those into the parentheses, and my factors will be x plus 1 and x minus 4. The next step would be to ask ourselves, what do we plug in for x that would make this equal to 0? So that would be a -1 and then a +4, because -1 plus 1 would be 0, and then a +4 minus 4 would be 0 as well. So now we're kind of at the halfway point. We have the x values. Now we have to figure out the y value, because remember, the solution to a system of equations is not only just an x, but it's a y, because it represents a point, an intersection between two graphs. So to get the y value, I'm going to set up the equation, and I'm going to substitute in my x value to get that y value. And I'm going to do it twice. And I could plug them into either equation too. I could use the 2x squared minus x minus 3, which is what I'm going to use, but I could also have used the x squared plus 2x plus 1. That would be okay as well. So that answer is going to be 0. And I'm going to set this up one more time. I'm going to plug in my x equals 4. And then that answer is going to be 25. That means one of our solutions will be -1, 0, and the other solution will be 4, 25, which also means that when x is equal to -1, the y will be equal to 0, and when x equals equal to 4, then our y is equal to 25. Now the final thing I'm going to show is how to actually solve this using the Inspire calculator. So let's jump into that. So here we are in the Inspire app. I'm going to start by adding in a graph, and I'm going to type in my first equation. And then I'm going to hit tab, and then I could enter in my second equation. So now I have my two equations here, and I know that the solution is going to be my intersection point. So what I'm going to do is go to Menu, and then Analyze Graph, and then I can select my selection tool. My intersection tool. And then it says lower bound. I'm going to move to the very left of my first intersection point, somewhere around here. I'm going to click enter. I'm going to move it to the right, just past that intersection point, so that it's a shaded area there. And then I'm going to hit enter again, and you can see that one of my solutions is -1, 0, so that confirms that. And I'm going to go back to menu again, same thing, analyze graph, number 6, intersection, number 4. And now I'm going to move. You could kind of see that that intersection would be somewhere up here, right? If the red one keeps going up and then it'll cross over with the blue, I'm going to just be to the left of that and press enter for lower bound. I'm going to move all the way to my right so that it would cross over that intersection point. I'm going to hit enter again. And then it'll automatically show that point. I could grab it, move it away so you can see that it's truly indeed 4,25 to confirm my other solution to this system of equations. So let's just take a moment to recap everything that was done because we did get through a lot. So the system of equations had 2 equations that are set equal to y. That's really nice. So you could actually set them equal to each other. By setting them equal to each other, that y disappeared. So then you only have an x variable and you could solve for that. In our particular problem, we set it equal to 0 because we would have to factor to solve. So then after set equal to 0, we factored it. We got our 2 x values. We plugged them back into either one of the equations. Well, we went with 1 in our situation, but you could have picked either one. And then after you plug the x values in, that'll get you the corresponding y's, which represents both of the solutions to the system of equations. And that's it.